3 on exponent laws. I'm guessing this is brand new for you. If it's not, then that's great. You'll find it really easy, and if it's not brand new for you, or if it is brand new for you, you'll still find it fairly easy. There's some good challenging questions towards the end. There are just a few. What they are, there's 3 rules, and we have to learn what they are and how to apply them. The first rule is called the product rule, and you must know, of course, that the product means multiply. And what I have written in green here is what I call the general case. And the general case is an A could be anything, B could be anything, and C could be anything. The important thing is that if you have 2 powers multiplied together with the same base, so this is the most critical part, the A and A, they're both A, right? Or D, or they're both 16, or they're both something, but they have to be the same. You could simplify that expression. You could simplify this by saying that's the same as A to the exponent B plus C. And you're going to see the y in a little bit. I have an example where it's kind of easy to show you the y. So just take my word for it for the first example, and then we'll see the y in a minute. So that's the first rule, the product rule. Let's just practice it first. So this one, example, 2 to the 4 times 2 to the 7. Again, notice they're the same base. What it's equal to is 2 to the 4 plus 7. This is this rule here, right? The B plus C part. And you end up with 2 to the exponent 11. And that's a single power, by the way. A single power. You're not evaluating it. You're not putting it in your calculator and getting a big number. That'd be a really big number, by the way. I think you'd be surprised how big it is. But anyway, it's not that. It's a single power is you write one base, one exponent. That's a single power. One base, one exponent. The next example is a little smaller. That's why I chose it to sort of show you how it works. So ignore the blue for a second here. Let's just go through the solution part. 2, by the way, is the same as 2 to the power 1. Okay? So when I write that out again, I write 2 to the 3 times 2 to the power 1. And then 3 plus 1 is 4. So it's 2 to the power 4 is what it equals, right? Using that adding rule. I'm using this example because they're small numbers. There's not many to multiply, to show you why the whole thing is true, why the product rule is the product rule. And it's just, if I had 2 to the power 3, that's 2 times 2 times 2, right? So those two things are equal to each other. 2 to the power 1 is just 2. So if I'm multiplying these out, and I did them just as numbers, I could go 2, 2, and 2 to represent these 3. And this 2 goes here. That's sort of like I'm multiplying them all. And that's 2 to the power 4, because it's multiplied by itself 4 times. Okay, so that's the y. The quotient rule which we're getting to is going to be the exact same idea, but it's dividing. That's why it's true. You never really have to show me this bit. I don't really need that. What I'm looking for from you is that you can apply this rule. You can do these types of questions. Okay, my point with this question is it doesn't matter how weird it is. The base can be anything. That's all. Okay, there's nothing to this. It's just exact same question, same base, and you add to get 5. Okay, doesn't matter what it is, what the base is. It could be a letter, it can be a number, it could be a decimal, it can be negative, it could be positive, it could be anything, and the rule stays the same. Okay, now this question I threw in here just to make sure you knew that I can't do it. 4 squared times 5 to the 6. I mean, you can evaluate that if you want. What I mean by evaluate is you could stick that in your calculator and find out what it's equal to, some number. It'll be a big number. But you can't express it as a single power because they have different bases. Okay? Leading us down to the quotient rule. The quotient rule, remember quotient means divide. And divide can be expressed as a fraction. And most often in high school, it almost always is. So you need to get used to the fact that this is a divide, okay? But you can see it's almost a natural. If the product was a plus, the divide, if multiplying is plus, the dividing is minus. Okay, just make sure whatever's in the numerator or whatever's the bigger is the first number there. And that you could write it this way, but like I say, we don't often use this, like this divide symbol. As a physics teacher or someone who teaches senior math, I never, ever, ever use this. Okay, it's always in this form. Having said that, my first example down here is in that form. But it's more just to show you it's the same thing. Okay, and you can see that it's pretty easy. You just leave the base, you subtract the exponents, that's it. And again, remember, because it's expressed as a single power, you're just leaving it, you're not evaluating it. You can leave the exponent there. Okay? Again, if you need more time, just hit the pause. All right, express a single power. This time you've got the form that I'm more used to, which is a fraction, remembering that 5 is equal to 5 to the 1, and so 4 minus 1 or 5 to the 3. Okay, and like I say, if the question said evaluate, then you'd go ahead and put in your calculator. 5 to 3 is 125. 5 times 5 is 25. 25 times 5 is 125. Okay, another one with x's, because it doesn't have to be. In fact, you're going to find it's most often not. It's most often going to be letters. Can be numbers, but most often it's numbers. And you can see it's the exact same. You just leave the base alone. It's not part of your math anyway. Okay, power rule. Remembering that power means exponent. So what if you had some base to an exponent, and then that whole thing was to an exponent? You could express that as a single power, because this isn't the most simplified way to do it. This is. And you have to, that x there is a multiply, your b times c at the top. So it kind of makes sense. Just to give you a numbers example, if I had 2 to the exponent 2 all to the power 3, it would be equal to 2 to the power 6. Oopsie. Okay? So you take those two numbers and multiply. So in this example, quite simply, 2 and 4, you multiply 2 times 4 and get 8. Okay? Easy. It's not always going to be this easy. I got harder ones, but the basic rules are very easy. So the putting it all together, I guess, is where it does get less easy. Just a sec, sorry about that. Just wanted to put this down here so we kept our focus on this question. Okay, so, and I didn't give myself much room or you much room, so work over here, I guess. But the first step I did in my solution here, okay, is I said, well, that's the same as y to the 1. And I did that because I don't want you to forget that when you do the next step, the y is there as well. Remember, we can't combine the x and y any more than they already are. They don't have they're their own bases, they're different bases. So I can't combine them. However, what I can do is I can sort of combine the exponents on the x's and combine the exponents on the y's. And what I mean by that, applying the power rule, I can apply the power rule inside this bracket to the x on its own and to the y on its own. So x squared all to the power 3 is x to the 2 times 3. Y to the 1 all to the power 3 is 1 times 3. Okay, so it's almost like, kind of like the distributive property, if you remember that. It's like you're distributing this power to each term, to each different base inside the bracket. And then you just, that's as far as I can go. There's nothing else you can do with this. Okay? The next one's a beauty. In the next one, we've got, and I chose to put a green X, by the way, just that we could distinguish between multiply, that's in multiply, right? Multiply and x's. Soon I'm going to stop writing x's, like x's for multiply, just because everything is just, if it's right beside each other in brackets, it's a multiply. Anyway, so the first step I took here was just to do what I did last time, which is to put the 1 on the y. You can skip that step. Like if you're doing a solution for me on a test, I don't need to see that. It's just that I'm doing this for you, so you remember that's why it is what it is. Okay. The next thing I'll do, I'm thinking in terms of BEDMAS, right? I need to deal with the brackets. I can't do much more with the brackets, but I can deal with these exponents. So before I do any multiplies, I need to deal with these exponents. So I distribute the 3 through, and that's just like the last question, right? So this becomes 6 because it's 2 times 3, and this becomes 3 because it's 1 times 3, and then this one doesn't really change. Nothing happens there. Okay, now I've got a big multiply, and I've got, like, because multiplying can kind of go any way, I can multiply the x to the 6 here by the x to the 4, and those are two things with the same base. So first I'm splitting it all out and writing it like this. Those are the two of the same statements, because multiplying can go in any reverse. 2 times 3 is the same as 3 times 2. You know, you can write it either way, it doesn't matter. So with multiplies then, you can put all the same, kind of like collecting like terms, right? Kind of put all the x's together and all the y's together. And now I've got product rule, right? So this was power rule. Now I've got product rule. I can add those two, 6 and 4 to get 10. And same thing, 3 and 2 to get 5. Okay? And that's really as far as I can go. I can get rid of that x there and just write it like that. And that's my most simplified expression. I can't be more simplified than that. Okay? All right, here's another beauty. Oh, just take a quick look at my note here on the side. Just for future reference, you'll stop seeing x like the multiply sign. That the multiply sign is unnecessary there. The bracket implies it. Okay. Okay. So it'd be great if you're starting to do this on your own. The first step that I'm going to do, again, thinking in terms of BEDMAS. There's nothing I can really do with brackets, but I can do this exponent. I need to distribute this 5 into this part of the expression. Okay, so that's what this is. 5 times 2 is 10, and that y, it's like y to the 1, right? 1 times 5 is 5, so that's where this came from, and the rest all stays the same. Nothing else has changed. Now in the next step, it's BEDMAS, but you remember that divide and multiply can go in any direction. I just need to collect all the x's into 1, and I can collect all the y's into 1. And the first way I'm going to do that is on the numerator. Okay? So what I've done here is I say, okay, x to the 10, it's multiplied by x squared, so that's x to the 12, right? Y to the 5 is the same as y squared, so that's the same as y to the 7. Because 5 plus 2 is 7. I think I might have said that wrong earlier, but hopefully you're following along. Y to the 5 times y to the 2 is y to the 7. And then the bottom, I just added the 1 there just to remind us. Okay, the 1 is unnecessary, but now I can do the quotient rule. So this question was a real complicated one because first we did the power rule. Do the power rule first always. The quotient rule and the multiply and the product rule can be done at the same time, or they can be done in either order, whatever you want. I chose to do the product rule first, but besides the fact that this step from here to here had to go first, after that you could do it all in one step if you wanted to. And we'll do more in class, by the way. So anyways, now I just say, my x's, I use my quotient rule. 12 minus 1 is 11, 7 minus 4 is 3, and that's it. Done. If you have any more questions, write it down, and we'll definitely do a few more in class as well. So we'll see you tomorrow.